Okay, for letter I, trying to find that out. From -1 to 2, 2 to 7, 7 to 14, we're adding the consecutive odds. We're adding the odd numbers here, +3, +5, +7. So if we continue on, add 9, add 11. Because it's not a consistent number, we tag this as neither. And then move it on. J. As I'm looking at J, I can see the 5s are staying the same, but the denominator is going from 1 to 2 to 4 to 8. And the only way that can happen is if you are having a geometric sequence. So to calculate that geometric sequence, go to Desmos. Type in the second number, the second term divided by the first term. And when you do that, your calculator will return a half. So you're multiplying each of those by a half. So this will be -5/16, -5/32, -5/64, and so on. And this is then what we call, again, a geometric sequence because we're multiplying by a half. And we have what we call as a common ratio, which is that half. On K, now again, because I've been doing this for years, I can see it's arithmetic. Again, what I'm doing in my head is taking the second term minus the first term, getting that magic number. I'm going to try arithmetic, and I'm going to see if that -1.5 continues to work from one term to the next. And it does. 5 plus -1.5 gives me 3.5, minus 1.5 gives me 2, and so on. So that so on takes me to 0.5, then -1, and then -2.5. And because we kept adding a negative, that means we are arithmetic, and we have what we call as a common difference, which in this case is adding a -1.5. Write that better. Letter L, it's not consistent. -1, -3, -7, minus, keep going and keep going. Or 1 minus, wow, I can't subtract. 1 minus 2, -3, -4, and so on. So I keep going. Nothing's consistent though. So we say we have a neither here. We were subtracting, but it wasn't the same number each time. This is how we tag it as neither. Okay, we can quickly see 16 to 4 and 4 to 1. That's some division happening. It's division of 4. And division of 4 is the same thing as multiplying by a fraction, multiplying by 1/4. So we have ourselves a geometric sequence with a common ratio. Now, if you see where I'm getting that 1/4 from, -1/4, I should say, I'm taking the second term divided by the first term, and that reduces down to -1/4. So I get -1/16, and I get +1/64, and so on. Letter N, not obvious. So when it's not obvious, I'm going to do one of my two tricks from here, okay? I'm going to try arithmetic first. I'm going to see if the second term minus the first term, whatever number that gives me, which in this case is -20.5, I'm going to see if that magic number works for the rest of those. If it does, it's arithmetic. If it doesn't, then I'm going to try to do division here and see if the second term divided by the first term turns out to be geometric. But it does. -20.5, I keep adding a -20.5 on, it works for me. So if I continue that sequence, I get this right here. Don't give you a lot of room. And because that kept working by adding a negative, we say we have ourselves an arithmetic sequence, and therefore we have ourselves a common difference, and that common difference is just that number you found. Letter O, don't worry about it. It's not a great one. It's going to be a neither. But for that last one, it should be pretty obvious. Multiplying by -3. And because we are multiplying, that is a geometric sequence, and we have what we call a common ratio. -3 does it. Again, how I'm finding that in my head, second term divided by the first term. And I'm checking to see if that magic number of multiplying by -3 keeps working, and it does.